All right, I want you to remember a date because this is one of those dates that's going to end up in the history books. We're talking about the moment a 200-year-old law of physics didn't just, bend. It completely shattered.
And look, this is not just another story about faster computers. Not even close. What we're getting into today is, well, it's way bigger than that. We're talking about a breakthrough so huge, so fundamental, that we're literally having to tear up the physics textbooks. I mean, rules we thought were rock solid for centuries, gone. A whole new chapter for humanity just started.
So what exactly happened? What broke? Well, Google just pulled the curtain back on a new quantum chip. And this chip, it did something that scientists have basically said was impossible. And the how, oh man, the how is where the story gets really wild.
I gotta be clear here. We're not talking about a chip that's like 10% faster. No. This is a leap so massive, it's like going from an abacus to simulating the entire universe in a blink. But honestly, the speed isn't even the craziest part. The real bombshell is what this proves about, well, about reality itself. Okay, so for 200 years, there's been this rule in science. It's been like the law of the land. It governed everything from the first steam engines right down to the tiny chip in your phone. And this rule basically drew a line in the sand and said, that's it. You can't get any more efficient than this. This is the absolute limit. It was a hard stop.
And now, that line has been erased. That hard stop, we just blew right past it. It turns out that down at the quantum level, nature has these hidden superpowers we had no idea about. So yeah, that 200-year-old rulebook, it's officially out of date.
And just to give you a sense of the raw power we're dealing with here, Google's new chip pulled off 1 trillion measurements in just a couple of weeks. You know what that is? That's more measurements than every other quantum computer ever built throughout all of history combined. We're not knocking on the door of a new era. The door's been kicked wide open. Okay, so how in the world did we get here? Right? This didn't just happen out of the blue. It's really the culmination of 3 massive leaps forward, with each one setting the stage for the next. So first, they cracked the code on making these quantum computers fix their own errors, and do it faster than the errors even happen. Second, they took them out of the lab, theoretically speaking, and started using them for actual real-world science. And then third, well, that's when they used all that power to do what we just talked about, to break the rules of physics. Let's dig into that first step, the error correction. The best way to think about it is like this. Imagine a race car just flying down the track at 200 miles an hour, and it's fixing itself while it's driving. That's what they've done. See, quantum states are super fragile. But for the very first time, we can now fix the mistakes faster than they pop up. And that unlocks a whole new level of calculations that were just impossible before. And this is where all that stability starts to pay off in the real world. They have this new algorithm that creates something like a tiny quantum echo right there on the chip. And what that does is it gives them essentially a much longer ruler to measure molecules with. It lets them see the super complex, tangled up structures of molecules in a way we just couldn't before. And for things like developing new medicines, that's an absolute game changer. So you see, this isn't just a win for the computer science nerds. This is a breakthrough for all of science. We are on the verge of this massive acceleration across so many different fields. Problems that have had us scratching our heads for decades, suddenly they're looking solvable. Just take drug discovery, for example. Right now, it's this super slow, incredibly expensive process. Why? Because we can't really simulate how these crazy, complex molecules are going to behave inside the human body. Well, guess what? Quantum computers can. They can do that simulation. So a process that takes 10, even 15 years, we're talking about crushing that down to just a few months. Just think about that for a second. Think what that means for things like personalized medicine. And no, it does not stop there. We're talking about the ability to design brand new materials from scratch, stuff that doesn't even exist in nature. Things like room temperature superconductors, which would completely change how we transmit energy, or batteries with 10 times the power. Imagine a car that goes 1,000 miles on a single charge. We're talking about financial models, climate models that can actually predict the future instead of just reacting to the past. The possibilities are just mind-blowing. And this is where things get really crazy. There's this incredible feedback loop starting to form. This isn't just one technology moving forward by itself. We're using our smartest AI right now to help us design even better quantum computers. And pretty soon, we're going to turn around and use those quantum computers to build entirely new kinds of AI.
It's this loop, this cycle, that's going to kick progress into exponential overdrive.
But, of course, there's always a but. A tool this powerful, it's a double-edged sword. With the incredible power to create, you also get the power to destroy. And we have to be really honest and clear about the massive risks that are coming along for the ride in this new quantum age.
Think about it. The exact same tech that lets us design molecules to cure cancer, it could also be used to design terrifying new bioweapons. The same power that could build us a perfectly efficient, clean energy grid, it could also be used to smash through every piece of encryption that holds our digital world together. We're talking bank accounts, national security secrets, everything. And let me be clear, this isn't some far-off sci-fi threat. This is a race, and it's happening right now. We are in a frantic race to rebuild our entire digital security from the ground up. It's called post-quantum cryptography, and we have to get it done before these new machines can break everything. And that deadline, it's coming up a lot faster than anyone is comfortable with.
So where do we go from here? What happens next? Again, this is not science fiction happening in 2050. The plan for just the next 5 years is incredibly aggressive, and it's already happening. And the pace is just going to get faster and faster.
Just look at this timeline. It is wild. This year, 2025, it's all about proving this quantum advantage works on real-world problems. By 2027, just 2 years from now, we expect to see systems that can run complex calculations without failing. Then by 2028, you'll be able to buy quantum computing time commercially. And by 2030, these things will be a standard piece of equipment in labs all over the world.
And that's why this is such a big deal. You have to understand, quantum computing isn't just another new gadget. It's a foundational shift. It's a new layer of reality that we can work with, and it's going to accelerate everything else. It's the rising tide that's going to lift every single boat, from AI and medicine to how we build things.
Which brings us to the real challenge, right? The biggest change isn't going to be the computers themselves. It's going to be in how we think. We have to start embracing all the weird stuff about quantum mechanics, superposition, entanglement, and see it not as a problem to be solved, but as a powerful feature to be used. The people and companies who win in this next era will be the ones who don't just use quantum computers, but who learn to think quantumly.
All these changes, all these compounding effects, they're going to completely reshape our world inside of the next 10 years. It's coming. It doesn't matter if we feel ready for it or not. So the only real question left is, what are we going to do with this incredible physics-breaking power? Are we ready for what's next?